Welcome back to OCR MEI Further Mathematics B. Today we're doing chapter 4.6, Revisiting 3 Variable Simultaneous Equations. When we do simultaneous equations, we often turn them into matrix form. Because you have 3 variables, in this case, you have a 3D simultaneous equation. When you turn that into matrix multiplication, you can use the inverse matrix to try to cancel out the matrix, just like you would do in division. So I'm gonna show you how to do that with an example, and I'll give you some questions to carry on. Alright then, so we have this whole simultaneous equation mess. First of all, we can write that into matrix form. The way to do that is to give the x value its own row, a column rather, and y value its own column, etc. So we have 3, 1, 2, just the coefficients of the x, minus 2, 1, minus 1, then minus 1, 1, and 1. This multiplied by an arbitrary x, y, z. If you expand this whole thing, you should get the left-hand side, which is what we want, and that would equal to minus 1 to minus 3 respectively. So in order to find x, y, and z, we need to multiply this whole thing by the you need to front multiply. So when you talk about matrix multiplication, you need to specify if it's a front multiply or back multiply. So in this case, we want to front multiply by the inverse of this 3 by 3 matrix. Luckily, we already know how to do inverse matrix. But for reminder, I'm gonna do that step by step here again. First of all, find the determinant. Determinant would be, let's see, is there nice? There isn't a nice thing. If there are 0, use the row with the 0. If there isn't, then just brute force it. So we have 3 lots of determinants for coherence sake. I'm gonna write the ones in that form. So if 1 take minus 1, so we have a 2 here. Then we take away the middle, which is a plus 2 times the determinant is 1 take 2, which is minus 1. Then we add the the minus 1. I'm not doing too well with health today, aren't I? Minus 1 take 2 is minus 3. So when you expand this whole thing, we get 6 take 2, which is 4. Then we add 3. So 4 plus 3 is plus 7. We've got this determinant sorted. Now we want to do another thing called actually this doesn't look normal, does it? Minus take 2, that's right. 1 take 2, and we have 1 plus 1, 2. 3 to 6, take 2, 4, plus 3. Yeah, should be right. Anyway, with that said, normally it wouldn't, if I have a correct, good sets of numbers for x, y, z, you wouldn't get some fraction of 7, but well, let's see what happens next. Now we want to do the determinant matrix, so I want this we have shown is 2, and this is -1, this is -3 as we have done. Then for this location we have -2 take +1, -2 take +1 is -3. The middle we have 3 take -2, which is +5. And for let's see, for this one we have -3 +4, which is straight like 1. For this one we have -2 +1, which is -1. And for the bottom we have 3 +1 gives me 4. Whoops, that is not in the right spot. This one is 3 take -2, which is 5. Now I've got this determinant matrix. Now I need to transpose and do the negative. So that would give me 2, 5, 5, 3, 1, -1, -3, -1, and -4. So this is the adjoint matrix, and we have a 1/7 before it, so the inverse is 1/7 adjoint. I'm gonna skip the step of writing all of that. And so if I front multiply this whole thing by the inverse, this should cancel, but I also need to front multiply by -1, -2, and -3. So essentially what I'm doing is multiplying by front multiplying the inverse to the right will equal to in simplified form, m to the -1 is the inverse, which is 1/7 times this adjoint. And as we have learned, this is identity, which means that this goes away, doesn't matter in multiplication. So we have x, y, z. So if we expand this inverse multiplying the solution, we should get x, y, and z respectively. So let's try that. So I'm gonna actually have to write that down, which is a pain. 5 -4 -3 -1 5. Okay, so leave the 1/7 outside. So just expand this whole thing will give us 1/7 lots of 2 times -1. So -2, then this is 6, so that gives us 4. Then we have this 2 is 4 plus, oh wait, oh no, I'm just dumb. It is 7. I just can't add 3. Basically I added 4 rather than 3, which is my problem. Phew, crisis resolved. Okay, 1 times -1, so -1 plus 10 is 9, then we have this is plus 12, so we have 21, and last row we have minus 3 plus 3, take 2, which is 1, then add net take away 15, so 1 take away 15 is minus 14. And if you expand this whole thing, we get 1, 3, and minus 2, which is the solution, which matches my answer. So that works. Yeah. I'm gonna cut away the middle part that I'm basically I just can't add. So yeah, I'm gonna cut that out, just so not to torture you guys through it. Remember that solving using matrices is not the only option. You're allowed to use Gaussian elimination in the exam. Just state that the reason you're using it. Just write literally. It's more efficient to do it with Gaussian elimination, given that we have a row with 2 zeros. That means they've given you a certain value of x, y, and z, then you get a 2 by 2 just 2 variable simultaneous equation with 3 variables, which is, you know, a lot easier than doing all these matrix stuff. However, if the question did state that by finding the inverse matrix of something solve these simultaneous equations, then no, you're not allowed to use Gaussian elimination. Yeah, so if you can find a row with 0 or a column with a 0, then use that row or column. You can cover up the row and column of your certain chosen row, and you can literally choose any row or column in the matrix and still get the determinants, which helps a lot when you are trying to save time. Time to get your hands on with some practice. I've got 2 3D simultaneous equations for you today, and I want you to find the solution. They're all unique, so it's not like before when you need to do the geometry, because you have a unique solution, which means that your matrix is not singular, and so you have a single point solution. Most of the time during the exam you would be asked to solve a certain simultaneous equation by using the matrix, and found that it's a singular matrix, so you need to interpret the geometry of the 3 planes described. For this one, it's a lot simplified for you. Just find the point. Again, you have 5 seconds to deal with, well, pausing the video. You can spend as much time as you want doing these. Yeah, I'll show you the answer in 5, 4, 3, 2, 1. So the answer is shown here. These should be all correct, so because I made the question using the answers. So if your answer disagrees, do check your workings. Signs matters, and as I've done in the examples, arithmetic errors occurs often, let's say. So yeah, that's it for this video. I hope you've learned something. If you have any questions regarding inverse matrices or anything to do with matrices really, because this is the last matrices video, if you have any questions, do let me know in the comment section below. And for now, thanks for watching, and I will see you on my next one.